Okay. It says 0 viewers on one, and it says 1 viewer on the other. Weird. Alright. As usual, I can't wait for people, so I'm just going to start. Today we're going to start working on the hardware renderer for this project. So I thought maybe we'd go down a software rendering path, so we did some rasterization. We did triangle rasterizing last time, and that was kind of fun. So figuring out how to draw triangles. And we didn't get to text rendering yet, because I think I'm just going to go straight down into hardware rendering, because that's what I want to end up with. First, hello Arctic Flare, welcome. It's a little bit quiet in here today. I think this is totally the wrong time to stream. I should stream in the morning, but whatever. People will view it later, and hopefully they'll get some value out of it. So I'm just going to pretend that this is a full room with hundreds of people, and they're all wanting to learn about programming. So, hardware rendering. Let's see what we're up to in this project. Oh yeah, I gotta make this bigger. 1, 2, 3, 4, 5, 6, 7, 8. Alright, so I'll just run the project. Let's get rid of these. Get rid of all this stuff. Let's see where we're up to. Right, last time we built a software renderer, as I just said, and we can draw triangles, like this yellow triangle here. Lovely. So this is basically a huge pixel buffer, and we just draw pixels directly into it, which is cool. That's how the old games used to work. But I don't really want to continue down this path too much, because I want to get into hardware rendering more quickly. So we've got this thing called a swap chain, and it gives us a buffer. And so basically what we need to do is set up a bunch of graphics resources on the GPU. So a vertex buffer, and we'll just start with the vertex buffer, I guess. And then we need to tell DX11 to draw using that buffer instead of using this pixel buffer that we have here. So, how do we go about doing this? Well, I'm actually just going to open that reference that I was using. Oh yeah, before I do that, I should probably talk about this community that I'm building. There's some cool people in here, very awesome people. So it's called Program Video Games. It's all about programming video games, not surprisingly. And we're just getting it started right now, but I'm hoping that it's going to be a really good resource for anyone who wants to learn and who wants to connect with other game devs who are interested in this kind of programming. So there's some spaces online already. I think we can make something cool here though. And the other thing I want to say is I've actually got a newsletter with a bunch of articles, including this one that I wrote just today, which is about how to think about memory management in a bit more of a, I guess, straightforward way that helps you conceptualize things based on time instead of, well, instead of just calling new and delete everywhere and then getting confused and having use after free bugs and all that kind of stuff. So it's just a little conceptual piece that I wrote, which is hopefully helpful. But what I actually wanted to go to right now was this DX11 example by D7 Samurai. It's very good. Highly recommended if you want to get into DirectX. And it's basically, I showed it last time, but it's just a straight line code of setting up a DirectX renderer and rendering this thing here, which is I guess a hollow cube, which is pretty cool. And you can see it creates the swap chain here, create the device context, and then the next thing we need to do is create a frame buffer, which we have not got. Oh, actually, maybe we do have a frame buffer. No, we don't. So we're actually rendering directly into where is it? This PP surface, if you remember, which is like a pixel surface. Hang on a sec, I need to turn the AC on. It's getting really hot. Yeah, my computer's cooling is messed up, so my graphics card is always at like 85 degrees, which makes this area very warm. I need to fix that. So basically what we want to do is not use this anymore. So we want to remove all of this stuff. We're not using software rendering anymore, at least not right now. Maybe we'll use it for something later, like drawing some UI on the screen or something like that. I don't know why we would do that, but could be fun. We don't need to calculate any triangles. We don't need to draw anything. We just need to display using the swap chain. And everything looks fine. And then if we run, we should get, yeah, a black screen. Awesome. That's good. We still have that problem of some resource is still being used. If we close this, you can see it's still running. I still haven't fixed that because I haven't done anything offline. So all of this is done fully on stream. I don't do anything off stream unless I say so, but I think the only thing I did was try to fix a bug so far, or otherwise everything else is on stream. So that's kind of the goal here. So basically what we need is we need a frame buffer, which is the same as a pixel buffer, except it's on the graphics card. So this will be useful. We need a depth buffer, which we're going to use for 3D, which is basically a big buffer, which tells, oops, I didn't want that, what the hell? Which is used to draw objects in front of each other, basically. And a vertex shader, we need one of those. That's to draw shapes onto the screen, which we'll need. Pixel shader, this is otherwise known as a fragment shader in OpenGL. And DirectX has this thing called a rasterizer. I don't actually know what this does exactly. I assume it rasterizes things. So takes this data and then turns it into flat pixels that we see. But I don't know why we need to create one. Maybe there's state that we can change about it and change how the rendering looks. I'm not entirely sure. Sampler is for textures. So we're not going to worry about this right now. Depth stencil description. I guess this is just to create the... This is a stencil buffer, isn't it? Depth stencil description. Not sure. I'll look into that. And what's down here? We've got this constant buffer is kind of like a uniform, if you're familiar with OpenGL, where we can write, what does that keep happening? We can write data directly to the shader and it will just be read from this constant buffer. So that's what that's for. Texture description, this is the texture that he's using in this program. We're not going to worry about that yet. So we're going to try and get the minimum viable stuff, which is going to be a frame buffer, I guess. Yeah, frame buffer. I don't even know if we need a depth buffer to draw a rectangle. I don't think so. Vertex shader, pixel shader, and we'll see how we go after that. So this is C++, so our code's going to be a little bit different. So we get kind of an idea from all this. So frame buffer is what we need. What have we got here? Swap chain, device context. Okay, that's all cool. So we create our device. That's what this is here. Interesting. Update swap chain description with actual window size is something we didn't do. Did I have that code in there? I don't think so. No. So I guess we should do that. swap chain, vtable, what was it? Get description. I think I called it SDC or just DC. SDC. SD. Swap chain description. And we need to pass in swap chain as the first argument because there's no this variable in C. Fantastic. Okay, now frame buffer, we're going to make that. I guess I should just do it in a line here. Why not? Am I missing something? Is ID 3D11 buffer? Frame buffer? Do I want to put an underscore here? Don't know. Does it matter? Oh, it's not a buffer, it's a texture 2D. Interesting. I guess that makes sense. Yeah, we draw to the texture, then render the texture on the screen. So yeah, I can't memorize all this stuff. You know, I've done this like 5 times before, but I just can't memorize it. So we need to get the buffer, create the description, then create a frame buffer render target view using this. Okay. Yeah. That's the wrong G. We need a big G, not a little g. And so we're going to pass in, what is it, buffer. What does that mean? Okay, I'm going to check this out. 1 second. D3D11 get buffer swap chain. I just want to know what this is referring to. A zero-based buffer index. I'm pretty sure I looked at this last stream. If the swap chain's effect is either sequential or flip sequential, only the zero index buffer can be read from and written to. Right, of course. So we can have a number of buffers available in the swap chain and we can write to any of them, I guess, at any time. So we need to know which one we're writing to. And then here we would have, is it ID, hang on, there's a specific way this exists in the C version. Where is it? IID, that's right. Okay, so IID, what are we getting the IID of? A texture 2D, because we're passing in a frame buffer. Okay. There we go. And this is going to be pointer to frame buffer, because it takes a pointer to a pointer. And this needs to be an address. Okay, and this is going to have to be cast, isn't it? Yeah, cast to avoid pointer. So we're going to do a pointer cast. Just a macro that I made. Cast to a void pointer. And that's might be confusing, but I'll go to the definition here. So it adds the pointer because it's supposed to be used for casting a pointer to a type, or a different type. So I added this here. So if we add this asterisk here, then it actually becomes void pointer pointer. So that's why I added that. And now we need the frame buffer render target view. So let's have a look at this. I want to look at what this is. I wonder if the search will work this time. Yeah, it did. Great. So it specifies the sub-resources from a resource that are accessible using a render target view. Okay, that's sub-resources from a resource. Okay. So what does that mean for us? We're saying that we're going to have a texture 2D that's got this color format available from our frame buffer? I suppose, yeah. So we're basically telling DirectX what kind of frame buffer we want. That's what this is for. Okay, that makes sense. So I need one of these. Did you see how slow that pasting was? It's crazy. Frame buffer, RTV, description. I'm going to make it initialize to 0 so we just don't have to deal with any weird bugs that may happen. So the format is going to be, yeah, DXGI format. So what this means is going to be red 8, green 8, blue 8, alpha 8, U norm. So that means 8 bits for red, green, blue, and alpha, so 32-bit format. U norm is unsigned, I think. I don't know what norm is. I guess I should look that up. Let's see. We've already looked at format. What a surprise. Okay. Yeah, blah, blah, blah. It's unsigned normalized. So normalize between two values, I'm guessing. I don't know what the values would be. Maybe there's a note at the bottom if I ever get there. There's a lot of formats, wow. Okay. Okay, unsigned normalized integer, which is interpreted as a resource, as an unsigned integer. Yes. Right, okay, so in the shader, it's going to be a normalized floating point value between 0 and 1. All zeros map to 0, and all ones map to 1. A sequence of evenly... Oh, okay. So it's basically... hello, Rock211. You're asking sprite sheet? We're not building a sprite sheet yet. We have to get a renderer working first. So this is just... Instead of using a floating point number between 0 and 1, we're going to use a value between 0 and... I guess 255, because they're 8 bits, to represent that range. And then it'll be transformed into a float on the shader side. That's what this means. Oh, now we know. Okay, and then the view dimension, D3D11 RTV dimension texture 2D. I don't know what that means, so I guess we'll look that up too. Texture 2D, okay. So view dimension. So it specifies which, how the render target resource will be accessed. Okay. Oh, I understand now. Right. So if we don't know what the access is going to be like, we can put 0, but it doesn't actually work, apparently. So used as a buffer, this could be a vertex buffer, for example, where we want to send positions of vertices in 3D, or we could send arbitrary data, I guess, but that's what this is for. 1D array is just a line of pixels. Sorry, 1D, texture 1D would just be a line of pixels, I guess. 2D would be, you know, an image. 2D array would be an array of images. And 3D, there's no 3D array. I guess because that goes into 4 dimensions, and that gets confusing. I don't know what this is. 2D texture with multi-sampling. Okay. Right. Well, we're going to use this as a buffer, right? Oh no, we're using it as a texture 2D. Yeah, this is the frame buffer. What am I talking about? We're not up to the vertices yet. Keep thinking we're making a vertex buffer. Alright, so we need one of these. I'm just going to copy this code. And we need to make this point to the long pointer to the V table. This is going to be device, frame buffer RTV. Oscar says, I hate that C interface for DirectX 11 is just computer generated garbage. Yeah. What's the problem here? Oh, I need to cast this as a ID3D11 resource. So I'm going to use pointer cast ID3D11 resource. No? Is there not underscore? No underscore, right. And I'm going to rename this. I know it's stupid because who cares, right? But it's just going to irk me. Okay, so now we should have a frame buffer. I'm just going to compile and run this to make sure it all works. Apparently. I guess I could look at the frame buffer. Let me just do a break here. Okay, what have we got? Frame buffer is here, and it does have a value, although I didn't set this to nil. Maybe I should do that first, just to make absolutely sure. Yep, okay. Looks good. We've got a fee table here. That's nice. Okay, good stuff. Frame buffer is set up. I'm gonna put a thing here, set up. Frame buffer. The debugger is called RAD, the RAD debugger. There's no, is there an about? There we go. The RAD debugger. It's very good. And it's free as well, which is nice. So, do we need a depth buffer? I'm going to say... Oscar asks if I prefer not to use COBJ macros. Oh, I don't know what that is. What is that? Let's have a look. Ah. What? Define COBG macros macro. Yada yada yada. No? Where can I find out about this? Is it here? Alright. Oh, I see. So I can just not use the long pointer to vtable every time by using some macro. Is that right? If I define this. Yeah, I didn't know about it. So let's have a look. Define this, I guess. Or maybe I'll define it up here. And then, what do we get? Something like how does it work? So it would be something like define this as this I bar 1 to bar 1. Alright, so we could just do device create render target. Is that right? Except now I'm getting an error. Does it compile? No. I think it has to be... I'm not sure. It looks like it should work. Create render target view device. Although I don't know the actual syntax for that particular function. Name of object underscore function name. Oh, so it would be like device underscore, or is it small d, big D? Not sure. I'm gonna not worry about that because I don't really mind. It's just a few characters. Delete that for now. Alright, so we're up to, we've created our frame buffer. Now we've got to let's make a vertex buffer, I guess. Actually, before we do that, if we go down here, there should be a clear color. There we go. Clear render target view. I guess I should make a depth buffer. Rock says RAD debug is good, and they use Remedy BG. I also use Remedy sometimes. I used to use Remedy, I guess. Now I guess I use RAD. Remedy is a really good product though. And also he's making his own MIP mapper, or has made his own MIP mapper in DirectX 12. That's cool. Clear render target view. So I guess we'll make a stencil buffer, but first I just want to see if this works. So we want to grab the device context. Clear render target view, and we'll pass in device context. Frame. Oh yeah, this needs to be declared outside, like up here. In fact, I'm going to make all these start as nil just in case. Oh, Oscar says the problem is I need to do this ID3D11 device underscore create device. And then that would exist if I define, what was it called again? COBJ macros, right? Yeah. Oh, or is it? Yeah, I see. Okay, it's working now. So we would pass in what? Wait, was that not? I swear that just gave me a Did you guys see that? That was a pop-up, right? So it would be something like this. Oops. But now it's not working. Unless you have to also write this. Nope. I think it's just confused. Let's have a look. Does it compile? No. Yeah, the LSP is not happy. That's what I get for using an LSP, huh? JSK says create device is not a function. Create render target view. Oh, right, yeah. That's fine. So this one, float pointer, so I'm guessing it's going to be vec4, right? So we'll just put a vec4 here. Do I have vec4 type? Yes. No. I've got vec2, and I've got color, which is unsigned 8. Okay. Let's just make one. Ah, jeez. There we go. 4 X Y Z W. Okay. So we're going to say a nice red, green, blue, and alpha. What's the problem? Oh, I didn't pass it into here. Huh? Oh yeah, it needs to be colored data. There you go. And this needs to be why do I type def basic types? Asks Rock. You talking about this? Because I don't want to write char, short, int, and long all the time, and I would rather write this version. That's basically it. Hang on. Am I supposed to pass in the frame buffer here, or the frame buffer? Render target view, which is this. Okay, now we should have a different color background, hopefully. We don't. Maybe I have to call another function first. Let's see. No, I don't think so. Well, that doesn't help. Okay, I'll have a look at this again. So we've got get buffer. I want present. There we go. I'm trying to figure out why he has 1 and 0 here. So 1 would be synchronized presentation after the nth vertical blank, or it could be depending on the swap chain. So let's have a look. Oscar says he enjoyed my SDL game dev series. Thank you. There is still a couple of episodes planned. I know it's been like 2 years or something. Yeah, the problem was I got much better at programming, I think, and then I didn't like my old code, and then life happened. I had a kid, and a lot of stuff's been going on. But yeah, I still want to make a circle shader and some screen shake and something else for that series. But I have to learn the code base again. But thanks. Thanks for saying so. I appreciate that. Flip discard. Right. And he creates 2 buffers. Yeah. So right before we were creating 1 buffer because all we were doing is drawing pixels to it, right? So we've got to go up to our swap chain here and have a look. We made 1 buffer. So we want to make 2 buffers, and we want to change the buffer. Is it buffer usage? No. Swap effect, yeah. So we want to do flip discard. So I think this is going to flip between the 2 buffers, and it will discard the pixels from the previous buffer. I'm pretty sure that's what that means. So if you imagine there's 2 pieces of paper and you're drawing on the one at the back that you can't see. So the one on the front is already visible. So you've drawn something to it, and that's what we're looking at. And then we're drawing on the one at the back. And then when it's ready, we flip it and we erase or just discard the ones at the back, and then we draw into that one. Again, I hope that makes sense. So that means we've got to make sure we're drawing to the right one when we do. Sample desk.count is wrong. I meant buffer count. Oh yeah, totally right. Thank you for that. Thanks for that. Ah, it's up here. Great. Rock says he used to program the blitter on Amiga, which had a double buffer. That's cool. I didn't think that would be a thing back then. Because it would take double the memory, right? Alright, so we've got a frame buffer, and we can render to it, and for some reason our color doesn't work. Why is that? Clear render target view. It could be because we're drawing to the wrong buffer. What is this? Front buffer and back buffer existed on the Amiga. Okay, that's cool. No, wrong button. Okay, so let's see. In his example, he creates a frame buffer using these values. Okay, all good. Maybe I do need to make a depth buffer. I don't know how DX11 works exactly. And we don't have a rasterizer. But we don't need one. We're not drawing any vertices yet. Okay, all good, all good. That's for vertices, that's for indices, we don't need that. So the clear color is, yeah, that's all good. That should be working for us. Is the color unnoticeable? It's the same color as this, so I don't think so. But let's make it red. Maybe you're right. Oh, you are right. What the hell? Did I get the color wrong? Is it supposed to be 0. Yeah, 0.018, I'm pretty sure. Yeah, I'm wrong, I guess. Maybe it's 0.18. Well, it's closer, but it's still wrong. Yeah, okay. Thanks for that, JSK. I hope I said that correctly. Totally just used the wrong color. How can we see what is going on in DirectX under the hood? I don't know. Alexander asks. I have no idea. We can use tools like RenderDoc to see various things. So if I open this application that we just made, where are we? Deep C build. Not sure if you guys have used this program before, but it's very cool. So I'm going to say we're going to capture frame 0, and we're going to launch, and blah blah blah. And we crashed. Well, that's not great. Okay, I'll use a different program because I think maybe something wrong with my program right now. So I'll show you this one, and we'll capture the first frame, launch, and well, it's just black, so that's not really interesting. Okay, let's. I can't remember the hotkeys, but we can just launch. No. Oh no. Did it crash? I'm not sure what's going on right now. Allow full screen, allow VSync. Oh, this path is incorrect. Maybe that's the problem. Alright, here we go. So this is the Metroidvania game that I've been working on in my course. And you can see we got up here capturing OpenGL, frame time, frame rate, press F12, print screen to capture. So if we go into the thing here, we can see if we press F12, that was apparently a screenshot, but we captured a frame, 1335, and then we can load it in here. We can have a look at the pipeline state. So you can see we've got a buffer with a size 128 by 720. There's a frame buffer here, and we can get sort of information from it. Show me stuff. There's not really much to look at because it's a 2D game, right? So we've just got two triangles in the middle of the screen. But you can look at things like the vertex input. So there's a bunch of different buffers here. And if you had, for example, like this, a bunch of vertices, you can look at all your data. This is really handy. I use this to debug when I was building what was I building? I think it was a voxel renderer. And I could see, oh, my buffer actually is full of junk data and it's totally wrong. And then I fixed it because I could see what it was actually doing instead of just looking at the screen, you know? Anyway, highly recommend looking at RenderDoc. We can close this. It's also available on Linux. I'm not sure if it's on Mac, probably. But yeah. Very cool. Okay, so that's all working well. We should have a front buffer and a back buffer. That's great. Now we need to draw things. So next step is usually vertex buffer, but I'm probably going to forget something because DirectX is different to OpenGL, which is what I'm used to. But I'm just going to say we'll try making a vertex buffer first, like this. And we need some kind of data to put in it, so let's see what this is. Right, okay, we don't want that. I mean, I suppose we could use the same data, get a rotating cube on the screen. It does look cool. It looks like this. Alright, you know what? I'm going to copy this, actually. And we need the indices as well, but we don't need the texture right now. I'm just not going to bother with it. I guess I'll just put it in a file called cube. Okay, so this is position, normal, texture UVs, color. I'm going to say we want positions. We don't want normals, or textures, or colors right now. Yeah. Maybe I should just draw a triangle first. I think this might be overkill. Yeah, I'm going to just draw a triangle. We'll try that first. Okay. So we want to create a vertex buffer. I think we make that from our device. Let's have a look. Create buffer. There we go. Device, and it's going to be no, we need description. D3D11 buffer description. All right. What is the? I just looked at it. What is the type here? Okay. Thank you, LSP. Thanks for breaking. D3D11 buffer description. Yeah. Okay, it just doesn't work sometimes. That's cool. Vertex, buffer, description. What do we got? Byte width, usage. All right, let's have a little look. That's not what I wanted. How to create a vertex buffer. Well, I wanted this. Did I type it wrong? I probably typed it wrong. So let's have a look. Size of the buffer in bytes. Okay, that's easy. The usage, how the buffer is expected to be read from and written to. Frequency of update is a key factor. The most common value is default. Well, that's good. It'd be weird if it wasn't. Right, immutable, can't be changed. Dynamic means, well, I'm going to see it here, but I'm pretty sure it means it's accessible to both the GPU read-only and the CPU write-only. And it's going to be updated frequently, right? Yeah, at least once per frame. So that would be good for positions of characters and stuff that are moving around, I guess. You'd want to be updating that every frame, right? So you'd use a dynamic buffer for that. And default is read and write access by the GPU. Okay. Right. Interesting. A resource that supports data transfer from the GPU to the CPU is what staging is for. Yeah, I think that's if you want to do compute shader stuff. You then put the results into a staging buffer and then copy it back to the CPU side if you need to. Anyway, we're just going to use default, I guess, for now. So, what do we have? Usage equals, of course it doesn't, D3, D11, usage default. What else do we have? Bind flags, what is that? How the buffer will be bound to the pipeline. Okay. Right, so this is a vertex buffer. I guess we just use this. Rock211 says, I wonder if the dynamic can use AMD's smart access memory. I'm not familiar with that. So, we'll worry about the size in a minute. What else do we need? CPU access flags. Well, 0 if no CPU access is necessary. So, we don't need to access this after we create the buffer right now, because we're just going to draw one triangle. But I'm going to want to write to it later, so I'm going to say we want to be able to read. No, we don't care about reading from it. Yeah, we only care about writing to it. Although right now we're doing default. So yeah, we'll just make it 0 for now. It'll break later. CPU access, well, I don't have to do anything because it's already set to 0, that's good. MISC flags, well, what are they? Let's have a look. Miscellaneous flags. Right, MIP maps, shared. What is shared? Texture cube. Okay, so there's a bunch of different things in here. Hardware protected. Alright, we're just going to leave this as 0 right now. Come back to this another time if we need to use them. Just try to remember that they exist. Byte width and structure byte stride. So that's going to be size of each element in the buffer structure in bytes when the buffer represents a structured buffer. So I believe that would be, if we have, like if you look here, oops, how it's got position, normal, textures, colors all in one kind of row, and then it repeats. I think that would mean we would say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this would be 11 bytes stride to get to the next row. But I'm not entirely sure. Yeah, that's what it is, I think. Wait, hang on a second, no. Contains elements of equal sizes. Use a structure with one or more member types to define an element. Here is a structure with 3 elements. So float 4, and bool, they're not the same size. But JSK says structured buffer is a shader thing. You don't need it for vertex buffers, only shader resource views. Okay, good to know. I remember I got screwed over a bit by the padding on the shader side, or in the buffer. So it was padding all of my values as basically float 4s, even when I passed in a single float, and it was adding 3 zeros. So we've got to watch out for that in the future. But now we need a size. So the size is going to be, how many vertices in a triangle? Well, we'll do a 2D triangle to start with. I guess. So 6. But it's 6 times size of float 32. So we're going to have 6 float 32s in there. Alright, now we can finally do this part. The initial data. So this is going to be our triangle data. And then we're going to get a pointer to a direct D3D11 buffer back. So that's an out value, the last one. Which means you need to make D311 buffer, vertex buffer. I'm going to put this up here. Oops. I'll pass that in a second. I'll just do the last one first. Actually, I'll just put 0 for a second. And this is going to be at vertex buffer. And this will be, it's going to have an error, isn't it? No? It's fine. No, that's good. The initial data. Okay, so we'll just make a simple triangle. Just trying to think about it. But basically, I don't really mind what the triangle looks like, but let's just say something like this. And we'll say this is 0.2, and this is going to be 0.8 on the x-axis. So 0.2, and then this will be 0.8 on the y-axis. So 0.2, 0.8, something like that. Yeah, I think that'll work. Let's see, triangle. I think I already have a triangle type. Don't I? No? Software renderer. We have a triangle, something, triangle extents. Oh yeah, right. It's a bit different, isn't it? That's fine. We'll say this is, to keep it simple, just a float 32 array. Vertices 6 equals. I don't need to do 2. Okay, 0.2, 0.2. That's the top point, and then we're going to go, I guess we'll go clockwise. Doesn't matter. Actually, it does matter. Did I set anything here? Or is it in the rasterizer? I think it's in the rasterizer. So we're not going to see anything because we don't have a rasterizer, right? But we can use renderdoc to check, hopefully. So the second one will be 0.8 on the x-axis and 0.8 on the y-axis, and then 0.2 and 0.8. Right? And we're just going to add this in here. And I need to cast it to what? D3D11 sub-resource data pointer. Okay. Wait. I'm getting confused. This is not the right thing. I'm pretty sure. Let's have a look. What's the function that we're calling? Create buffer. It's not this. It's device. Create. No. Device. Yeah, this is not where we pass the data in. Okay. We need to pass the data into this field on this struct. So we need to make one of these. vertex data, I guess. So this would be vertices. The pitch is going to be kind of like what I was talking about earlier, I think. And let me go back to this. The pitch is going to be how long each row of one vertex is. So in this case, it's going to be 2. But is it in bytes or is it in... Do I need to calculate the size? Let's see. It's only used for 2D and 3D texture data and it has no meaning for other resource types. But it's in bytes, so that's good to know. In that case, I don't need to do anything to it, right? Because this is not a texture. Right, okay. Oh, I think the reason that RenderDoc crashed, by the way, is because I've got this in here, debug break. Maybe? Didn't know how to deal with that. Because why would it? It's not a debugger. Okay, program's running. Let's see what RenderDoc says. And we'll just change the working directory to here. Okay, I'm just gonna launch. Okay, and F12. Let's have a look. See, it's already coming in useful. So we've got an input assembler, and because we're not using the vertex buffer, it doesn't show up, which makes total sense. So there's nothing coming into the pipeline because we haven't set up the pipeline properly. Oh, that's great. So what I'm going to do now is actually do that debug break thing again, and I'm going to check our vertex buffer, which is here. Make sure it's not nil. JSK says resource inspector should be helpful here. Is that in... Oh, it is, yeah. Okay. Let me have a look. Did I compile that? Maybe. I'll just recompile. Oh, I can just look at it here. Resource inspector. Oh, I see. Immediate context bindings, immediate context, render target view 45. So you can see we've made a swap chain with texture 2D, which is this. This is the thing. Swap chain image 35. That's cool. Yeah, the buffer's not here yet. I think because we're not using it, or we haven't called something to put it in the pipeline. But this is actually cool. I didn't know about this. So we can see if we ever want to do something with one of these buffers, the row pitch is 7,680, which I didn't know. So that's cool. And I'll be right back. Sorry, I need to pee really bad. Okay, I'm getting really hungry. So let's get this triangle on the screen, eh? I thought I'd be fine. I just cooked lunch before this, but wasn't enough, I guess. Okay, let's have a look at this wonderful example again. So we created a buffer. Oh, interesting. Vertex buffer description, sub-resource data. Yeah, alright, so he passes in that. So that all looks good. Oh, I didn't check actually. Just to make sure. That we get a value. Hang on a second. That's weird. Did that not build? It did. Okay. I am confused. Cannot open debug.exe for writing. I think... Okay, I know what happened. When we opened it in RenderDoc, and then we closed it, it didn't close properly because I haven't fixed that bug yet, so it's going to be in here somewhere. Where is it? Debug. No? Maybe it's just because RenderDoc is still open. I'll close it. What about now? Cannot open debug for writing. But it's not here. Oh, there it is. Delete. Get out of here. There we go. Fantastic. Okay, now, if we have a look at our vertex buffer, it has a value, and it's got a vtable that looks like a vertex buffer vtable. That's good. Fantastic. Great. Although actually, never mind. I was going to go on a tangent, but that's cool. Will never be updated. Yeah. Neither will ours actually. So maybe I should set it to immutable. It doesn't matter. Who cares? Who cares right now? We just need to figure out how to use the buffer, which I guess there was a page in one of these Microsoft websites how to use a vertex buffer or how to set up a vertex buffer. How to create a vertex buffer. Great. Yep. So we define a structure that describes a vertex, for example, position, color, etc. Allocate memory using malloc or new. No, I don't want to do that. Create a buffer description by filling the description. That's cool. Create a sub-resource data structure. That's what we just did. Call create buffer. That's what we just did. Okay. Right. Remarks. Okay. Create a second buffer with staging. Fill it with map to copy blah, blah, blah. Okay. No, that doesn't tell us how to use the buffer, does it? I'm excited to get up to command lists. I really like command list as an idea, but I haven't used it before. Anyway, that's weird. So we've made the buffer. And I guess we need to create a shader. So let's do that. So where's the shader stuff? Did I go past it? There we go. Vertex shader and pixel shader. All right, that's fine. So yeah, that's right. Our shader source, I think it's shader source object. I haven't checked what CSO stands for, but basically what we're going to do is we're going to use the DirectX compiler, pull in our source code, which will be a shader source file, and then compile it into this blob here, which we do, where is it? Is it this one? Yeah, I think it's this, create vertex shader. And the cool thing about DirectX is it has really good, well, it has decent error messages, unlike OpenGL. Although I think that got better in the later versions, but yeah. Cool. So let's just do it. I'm gonna just type some code. Create vertex shader. ID3D blob. Shader CSO. It's a vertex shader. Yeah, D3D compile from file. Okay. Do I not have the compiler? I don't. Include D3D compiler. There we go. So the file name, we'll just call it vertex.hlsl. D3D shader macro. Don't know. What is that? Let's look up this. That's not the right thing. D3D compile from file. Defines shader macros. Each macro definition contains a name and a null terminated definition. Right. I'm going to look into that one day. That sounds interesting. But for now it can be nil, nil, entry point. So this is the function in the shader, I think. So what did he call it? Vertex shader main. Oh, that's right. In HLSL you can define the vertex and the fragment shader in the same file. So then you could just call this shader or whatever. And then you just say, okay, it's going to be vertex main is the function name. Whatever you want to call it. Target. What's the target? Right, it's the version. So shader model 5. DirectX 11. So we want to say vertex shader 50. Okay. I mean, I know it says it in the other code, but I just wanted to make sure that we understood what we're talking about here. So this is the latest version, and it's a vertex shader. So therefore, that's the target. Okay. Flags. What are the flags? Compile options. And flags too. Okay. Very good. Ah, debug. No pre-share. Okay, there's a bunch of things here. This might be handy, actually. Directs the compiler to insert debug symbol information into the output code. Yeah. So I'm just going to put them as 0 for now, but that's cool to know. And then the code is going to be vertex shader CSO. No, that's the blob. No, that is that, right? And then yeah, no. Okay, this is not. Okay, I'm passing an unsigned short to long pointer to C string. Right. There we go. Okay. Then we want to call create vertex shader from the device. And I'm just going to copy this. Once again, copying something and changing it very slightly. Do you guys ever do that? When you copy someone's code, you're like, oh, I don't like how they did this thing slightly different to how I do it. And yeah, right, we need a thing to point it into. D3D11 vertex shader. I'm going to put that up here because I'm sure we're going to use it in our main code. This needs to be vtable, and we need to pass in. This is getting very wide code. What's the problem? Too few arguments. Oh, because we need to pass in device here. Great. Input element description. Oh yeah, right. So these are called vertex attributes in OpenGL, which is basically wait, no, these are not vertex. Yes, they are. Yeah, these are vertex attributes. So in our case, we've only got position. So all we need is this, except it's going to be a bit different because this is a 3D vector, but we have a 2D vector. So, yeah. Come on, give me the correct element. No. Input element. Description. I guess I'll call it input element description. Oh no, it's an array, isn't it? Yeah. So we want input slot 0. Wait, is this the correct order that it shows here? Semantic name, semantic index, format, input slot, right. So we'll just call it pose. Semantic index is 0. The format is IDXGI format. No, it's... I keep forgetting this. DXGI format, right. It's not an interface, it's a format. So red 32, no. Red 8, green 8 underscore float. Hang on. It's not 8, it's 32. What am I doing? 32-bit numbers. Red, 32, green, 32, float. There we go. So this basically means if you imagine an array of 2 floats, one is red, one is green, except in our case, one is X and one is Y. So we're just going to set the Z position to be, or the Z position. Don't know why I said Z. The Z position to be 0. So the input slot, yeah, 0, 0 per vertex data, 0. Yeah. Okay, so align byte offset 0 per vertex data. 0. Great. We didn't really need to make that into an array. that's fine. We're going to add other attributes here later. So we need an input layout. Whoops. I kind of want to know what this is. Holds the definition of how to feed vertex data that's laid out in memory into the input assembler stage. Right. Okay, so basically we're going to use this, and then we're going to call a function, and it's going to put what we put here into this, which I guess the graphics pipeline is going to use like this. So create input layout, and we've got to pass device in here. And then this is going to be input element description. And the same thing here. What's the problem? Problem is this needs to be vtable. There we go. Okay, we're almost there, I think. We also need a pixel shader. Actually, we don't need a pixel shader, do we? I might as well just make it anyway. I'll just copy this. Oops. I'm still getting used to standing up while typing. It's weird. Okay, almost there. What's the error? We didn't pass device. How do I keep doing that? Pixel shader. Gonna put this up here. All right. So we create a vertex shader when we create a pixel shader, otherwise known as a fragment shader in OpenGL terminology. And I'm going to change this to shader.hlsl. Oh, good. Now, rasterizer, I guess we should make one of those. We don't need a sampler right now because we're not doing textures. Okay, rasterizer description. That's fine. I think we need to reference rasterizer state in the drawing section, so we're going to put that up here. And this needs to be a vtable pointer. There we go. Whoop. Okay, created a rasterizer, yada yada yada. Now, I think we have to do something else. Like, does our swap chain just know about this? Because I'm pretty sure we haven't said anything about these buffers to the swap chain. Let's see. Apparently not. Okay. Well, we're going to send a triangle list using our input layout, which I need to make available. That was here, wasn't it? Yeah. And then we want to set our vertex buffer, set our index buffer, which we don't have. So I guess we just don't set an index buffer. Do we need one? I wonder. Set the shader. We don't have a constant buffer. We haven't set up a viewport. Okay, what happens if we just do this first? Basically, clear the screen and then I want to see what renderdoc says if we call these three functions here. Oh, we don't actually have a shader source file yet, so we're going to have to do that as well. And what is stride in this case? Right, so yeah, 11 floats like I thought, and then offset is just 0. So we can just say 2 and 0. I still need to figure out why this works. Is it an anonymous struct with no type? Probably cast it to an F32? I don't know. I need to look that up at some point. Oh, it doesn't work in this case. Because we want uint. Right. So it does work, we just didn't pass the right type. Okay. Well, we need to make the shader. So let's have a look at the shader code here. Right, so it's pretty similar to OpenGL. I'm just assuming that most people have used OpenGL rather than DirectX, if they've used anything. So I'm going to call this shader.hlsl. So we don't need a constant buffer, we don't have that. Vertex description in our case is float2 position called pos, that's it. Pixel description, position, texture, coordinate, color. So this is what's going into the pixel shader, I guess. Where does it use? Yeah, the output here. Right, so pixel.textcoord. So I'm going to say all we have is a float4 position. Why is it float4? Oh, because there's that W coordinate thing. Okay, I'm not going to worry about that. Just going to leave it. This is going to be vertex main, and this is going to be pixel main and pixel desk, I guess. So the position is going to be, JSK says I should enable debug layers as they'll complain about necessary state missing. Yeah, I should. I'll do that. So I'm just going to say here, float for vertex.position 0, 1. I'm not going to worry about transforming the matrix because we're sending in normalized coordinates, so we should get a result that looks like it's on the screen. I mean, it should be on the screen. Sampler, no. We're just going to return, oh, hang on a second. Toast Bomb Halo says, is this Emacs? No, this is an editor called Helix. It's like a combination between NeoVim and Cocoon, if you've ever heard of that. Cocoon is pretty niche, but it has really nice stuff like multi-cursor. You can see really easy multi-cursor stuff and a bunch of other features. But the good thing about Helix is, actually, if you want to look at my config, it's just this. So I've got a theme, I just set a few options, and I set some custom keys. So this is my build command. This is my run command for Odin, and that's it. But the downside is you can't really customize it. There's no plugins yet. I don't really care about that though. So we don't want to sample. We want a pixel to be either... I guess we just want to return a color, right? So we just say return float for red. And that should say, I guess we don't need this then, right? What's the point of passing this in here? Texture coordinate color, yeah, we don't need that. So I'm just going to say this returns, I'll just leave it, but I don't think we need that right now, but we'll need it later. So we don't have a texture to D, we don't have a sample state. We've got a position, and that's it. So hopefully that works. Let's see. Compile, okay, I'm gonna run. Well, we've got an error. I can't see what the error is, so maybe it's a good time to turn on those debug layers. JSK says it's a flag in D3D11 create device. All right, let's have a look. So I've got, oh, I remember this. I had a problem with this last time. I've got device debug as a flag. Let's see. Here we go, layers. So you can see I've been looking at this. In the last stream, or the stream before, when we set up the software renderer, the debug output defaults to debugger output. Right, okay. So that would be somewhere in here. I don't see anything here. But let's see. Did I just click something? I'm going to close all these. I'm getting confused. Okay, close, close. All right. D3D11 create device flag. Creates a device that supports the debug layer. To use this flag, you must have this DLL. I believe that is here. Yes. Toast Bomb Halo was asking if Clang D works well even though I'm compiling with MSVC. Yeah, it's pretty fine, and you can see it active now. I haven't had any issues with it really, but I will say I'm working in a code base that has only Windows and DirectX. I don't even use the standard library or any libraries. So you might have to create something like a compile flags.txt file when you use libraries to tell it things about your setup. Alright, create device. Yeah, okay. That's what we're doing. So the debug layer. So we've got this. It's an extensive additional parameter and consistency validation. Well, that's nice. You must install the DirectX. Yeah, I've got that. Then specify device debug. Okay, I did that. If you run your application with the debug layer enabled, the application will be substantially slower. But to ensure the application is clean of errors and warnings before you ship it, yeah, okay, thank you. Right. So I did enable it. Let's see what happens if I run it from the command line instead. Nothing apparently, that's weird. Oh, because I've got a debug break in there. 1 second. Is that why? Oh, I don't. Okay, weird. Just doesn't work? Okay, that's strange. What's this output.txt? Something, something. Oh yeah, that's when we were building a text, a string builder. Right, so it's running and it's getting up to this point, I'm guessing, and then it just exits because this failed, but I don't know why it failed. I think what I need to do is enable the console, because this right now is a Windows subsystem program, and if I change it to console, I might get something. Let's see. I don't know if that's even going to work now. Alright, we got nothing. Okay. Well, what about now? No. Okay. Let's see. I guess we'll just inspect things. Right. So obviously this is not being created correctly. Why? Actually, I'm going to try one more thing. Isn't a null... Well... Yeah. So the shader CSO is null, which means I guess this failed. Compile from file. Oh, hang on a second. Wait, shader. Yeah, it's here. Okay. Does this return a value? Compile from. It returns an H result. Okay. Let's have a look at what that is. Unspecified failure. Okay. Not the most useful. Let's just double check all of the arguments here. All the parameters rather. Maybe it doesn't like my formatting. I don't know if there's rules about this, so I'm going to change it to this. I'm sure it's probably fine, but maybe not. JSK says the easiest way is to call fxc from command line. What does that do? Right. DirectX shader compiler. Oh, right. So try to compile the shader from here. Gotcha. So I put in, let's go back here. Right. That's great. I didn't know about this. That's very useful. I'll make this bigger. So, syntax error, unexpected float constant, line 15. Very useful. Thank you for that. Yeah, there's a comma missing here. Entry point not found. So we need main apparently. I don't think that matters because, well, we'll see. Hey, look at that. Thanks, JSK. Save the stream. That's awesome. /T/E and /FO are the flags if you want to look at. Oh, that you do want to look at. Okay, what are they? Let's have a look. /T, target profile. /E, entry point name. Oh, yeah. Okay, right. So we could change it to /E shader underscore. No, vertex shader. Vertex main. And then FO would be the output file, right? Output object file, yeah. So we could call it vert something, I don't know. Compilation failed. Oh. Interesting. Invalid VS20 input semantic POS. Wonder, I don't understand what this means, but is it because I didn't set the profile? Which is /T, right? VS50. Right, yeah. Gotcha. So we've got the vertex shader compiled here, which just looks like garbage to us, mostly. Oh. Cool. Well, there's actually quite a bit more ASCII in here than I expected. Not, you know, a lot, but a little bit. Cool. Alright. Well, that's handy. Thanks. So, if we compile the shader, and we use the shader, did we use it? Well, we set the input layout and we set a vertex buffer. So let's see what happens in render doc now. And you gotta remember that we're gonna have to find this in the task manager and close it afterwards. But let's see, launch. Okay, it's running, F12. Let's have a look. Hey, look at that. We got a buffer with, hey, where is it? Buffer 46. Byte width of 24 bytes. JSK says ID 3D11 device context is the equivalent of the GL state machine. Whenever you need to set something, look there. Right, I see. So that would be device context and then look through all of these things. I see. There's a lot of stuff here. So set shader, set the pixel shader. Interesting. Okay, so would that be VS? Yeah, VS, blah, blah, blah. Okay, cool, thanks. Let's look at this. I just want to look at the data in here. I can't look at it. Oh, there we go. That looks wrong, I think. Why is it in hex? Is this the wrong buffer? Well, the lower panel has a format where you can set, you can input a C-like struct in there. Which lower panel? That's the call stack. I haven't used RenderDoc that much, in case you couldn't tell. I've used it a bit, and it's been really useful so far. In the buffer constants view, buffer constants. Okay, let's see. Pipeline state, buffer 46. All right. P buffer. No. I feel like I'm lost. How did we get there just a second ago? Maybe here? It's a tab. Okay. Oh, here, right. So you're saying I can put a struct in here? There's an arrow next to the resource that opens the view. Right. Would that be this? Yeah, I gotcha. Okay. Let's see. Render doc. What are these called? Format? Buffer format? How do I specify a buffer format? There we go. Okay. Let's have a look, shall we? I'll see what this does. Probably nothing useful. Float a, what's going to be X and Y. Okay, but how do I apply? Hey! Thank you. That's very useful. Float 2 is allowed. Oh, okay, so we could just do... And let's have a look at the docs. Right. Something like this. Float 2, data, apply. Okay, great. All right. We have the correct data in the buffer. That's awesome. We don't have a mesh because it doesn't know how to draw it, I guess. Or we haven't drawn it. So let's close this again and then go to the task manager and find it. Oh, I just saw it. Debug. Here we go. All right, cool. Thanks. I'm learning so much today. Thank you very much. So, to draw a triangle, well, we want to set the shader. We don't have a constant buffer. We don't have a viewport. I wonder if that's going to be a problem. Because we don't have a rasterizer. Oh, we did set a rasterizer up, but we don't have a viewport. I think that might be an issue. Just to... But we'll try without it first. So we'll grab this. Yes, yes. So set the shader to the vertex shader. This is going to be nil. And it's going to be 0, and this is going to be device context again. Fantastic. All right. Now we'll set the rasterizer state. I'm just going to try doing it directly like this. RS set state. Very good. Device context. Rasterizer state. Actually, let's look at that. I need to set the... Where is it? Fill mode, fill back, cull mode, cull back. Here we go. Front counterclockwise. Oh, it's already set to false. If I put a 0 here. So the front, in our case, is clockwise. Okay, cool. Chasky says, viewport rendered target, vertex shader, and pixel shader have no defaults. So consult debug output when in doubt. Yeah, I would like to actually get debug output working. Let's have a look. Well, that's definitely incorrect, but I don't have any output here. So there must be a step that I'm missing. Set the shader. Present and a draw call is required. Oh, did I comment out present? I didn't mean to. That could explain a lot. Right, can't complain if I don't try to draw anything. Okay, gotcha. Okay, so I'm going to draw... Where's the draw call? It's here. I'm not going to draw indexed, so... I don't know what else we can draw. Draw... Apparently we can draw auto. Whatever that means. Okay, draw what? Device context. Draw. Vertex count, start vertex location. Okay, easy. 3 vertices. Location is 0, and we're going to pass in device context. Okay, so I guess we'll try that first. Oh, there we go. Debug output. Very good. Cool. Alright. Vertex buffer, stride 2 at the input vertex slot 0 is not aligned properly. The current input layout imposes an alignment of 4 because... Oh yeah. Right, so we need to always have a stride of 4, is that right? We can't have a stride of 2. It was called byte width, is that right? No. Structure byte stride. Hang on a second, what am I missing? It was here. I don't know if that's... Alright. Input vertex slot 0, stride 4, which is less than the minimum stride, logically... Okay. It's in IA set vertex buffers. Oh. Is it? Yeah, right, that's what I was just looking at. There should be a method name in the debug output. Alright, let's have a look. Okay. Well, this says it's in draw, but I see the problem. This is okay as hardware is perfectly capable of reading overlapping data. However, the developer probably did not intend to make use of this behavior. Right. Vertex buffer stride too small. Less than the minimum stride logically expected from the current input layout, which is 8 bytes. Okay, let's have a look at the input. Not that input. Stride should be in bytes, yeah. Oh, I didn't do bytes, I did just 2. Gotcha. Wait, that's 2 bytes. 2 times... Hey Daniel, how you doing? If I do size of byte, it's going to be exactly the same thing. Hang on, I was looking for something up here. Where is it? Input element description. Two floats. Oh yeah, 2 floats. Thank you. I'm an idiot. Oh, we hit a breakpoint. Where is this? In NTDLL, okay. I'm gonna make these variables. Alright, what is this about? I can't tell. I guess we'll have to step through. Hello? I think this is a misclick. Let's see, performing full link, yeah. Okay, I'm gonna put a breakpoint at the entry. Okay, that's... What? We didn't even get to the entry point yet. How did that happen? Wait, or is that the entry point? It's running now, apparently, but... What? JSK says, happens to me when using RADDBG. It's the disassembly window opening up constantly. Right, yeah, that does happen a lot. But I think... I don't know exactly what's going on here, but what I'm going to do... Is there a way to make it stop opening up? I don't know, actually. But if you figure that out, please let me know, because it's a bit annoying. I'm going to delete all this stuff. And we're going to try again. Okay, error starting process. Did it not compile properly, maybe? Oh, I just deleted it, of course. I didn't compile it. Now we'll compile it again. There we go. Run. Okay. What just happened? What did we change that could have caused this problem? Nothing as far as I know. I'm really confused now. This was just running a minute ago, right? We all saw that. And then I changed nothing, and now it's not running. Or is it the rasterizer description that I changed? I don't think so. That's weird. I'm going to try running it in the terminal. It said, can't you just continue? Well, yeah, when I press continue, it doesn't open though. So it is running. Now I've got to delete it here. Oh no, it's not running anymore. Good. Okay, let's see. F5, continue. Yep, but now it's not. See, there's no actual window. And if I press Ctrl-Shift-X, where are we? We're here. Where is this? We're inside somewhere. Get description. What is going on here? So we're still inside create device and swap chain somehow. Is that what I'm seeing here? So if I press continue, where do we get to? Win main CRT startup is before main. If that's what you're looking at, it's hard to see. Right, okay. I don't have a main, I've just got a win main CRT startup. But the problem is, well, I don't know what the problem is, but we seem to be going into here and not coming out. Okay, apparently we are. Alright, I'm just going to close this, open it again, run, still the same problem. Yes, I want to exit. Very weird, because as you just saw, it's running from here. That's correct. The reason I keep checking task manager is because sometimes it doesn't close properly. I haven't fixed that bug yet. But if we look at maybe remedy BG, can we open it in here? It does feel like stale compilation. That's why I have in my build script usually, maybe I didn't put it in this project, I delete the PDBs. Yeah, just gonna. I'm also gonna delete ILK, but there's no object files, right? No. I don't know. All right, let's have a look. Let's see if this works. Okay, remedy BG is working. Interesting. Rad DBG not working. All right, I'll have to report this to Ryan if it's a rad problem, which it seems to be. So I guess over to remedy BG for now. Cool. What are we doing? Right, we were trying to get triangle drawing on a screen. And so we were checking if we could set the rasterizer and etc. But we do need probably a viewport. Set the pixel shader. We don't have a sampler, so we don't have to worry about that. Right. So set the vertex shader, and then we can use the pixel shader that we set up. So pixel shader, class instance, I think that's going to be nil and 0. Okay. Did I just type a bunch of random stuff? Okay, all good. Okay, still running. That's good. What else do we need? We probably need a viewport. How is the viewport created? Okay, just the swap chain buffer description height, width and height. Okay, we'll just grab this. I think this is just called SD. And this needs to be outside here. But it can't be because that's inside. So I don't even know if that's correct. I think it is. Anyway, viewport equals this. Great. Now we need to use the viewport. So I don't know how much of this stuff is required. Did we set the input layout? I think we did, right? Yeah. Okay. So set the viewport before the rasterizer state, I guess. Number of viewports. I guess it would be one viewport. Interesting. So you can have, of course you can have multiple viewports. It's not even a question. Okay, we're still compiling and running. I don't know if anything's working, but actually, is there debug output here? Here we go. The pixel shader expects a render target view bound to slot 0, but none is bound. This is okay, but it's possible, right, that I forgot to do something. Yeah. So render target view binding is what I need to do, I guess. Is that here? Render target view. I'm not seeing RTV anywhere here. Oh, here it is. Set render targets. OM set render targets. What is OM, I wonder? How long have I been streaming? 2 hours and 12 minutes. Wow. My eyes are starting to get quite sore. Output merger is what this is, says JSK. Okay, thanks. Number of views. Alright, well, one view and frame buffer RTV, and this is going to be nil. I don't know if you can have no stencil. What's the problem here? I'm apparently missing a parenthesis somewhere. I'm missing a comma. There we go. Okay. Great. And we don't have a depth stencil. No blending. Okay, I'm going to use this. Okay. We've got no errors. That's good. We also have nothing on the screen. That's not as good. But let's have a look at render doc. Wouldn't mess with blend state? Okay. You think it's by default fine to just not set it? Well, we already know about our vertex buffer being in here, but what about our pixel shader? Rasterizer, fill mode solid, color mode back, front is counterclockwise. No. All good. Not scissoring, not doing anything like that. Maybe we do need a depth buffer. I don't know. So merging this with nothing. Always check the mesh viewer to see if there's actually a mesh. Okay. Would that be in the input assembler? Depth is optional. That's what I thought. So there's no mesh here apparently. Hey Voxel Riffs, how you doing? So no mesh, no current draw action. Click on the draw call on the left. Oh, right, yeah. Okay, great, thanks guys. Cool, so we've got a triangle. It does exist. And it's red. That's the right color. Okay, but we can't see it on the screen. I didn't mean to rotate it. Ugh. Yeah, can I reset it? Is that... Yeah, there we go. So... Okay, I think there's white lines at the edge of the screen. So it should be visible up there. Interesting. So I think we're just missing one step, or the swap chain might be configured incorrectly. So getting buffer 0. I want to look at the image. Where is it? Swap chain image 35. Yeah, well... Check if it's culled by the rasterizer. Can I do that in render doc? Oh, and the rasterizer here. Okay, draw. I don't see anything in here. Rasterizer state 50. Right, okay, that's not what I want to look at. So... There's no scissoring. Vertex count is 3. Okay, so it's... This is the mesh viewer, but we're on the rasterizer stage. I don't know if that means it's culled or if that means it's fine. I'm guessing it's still there, considering it's still showing up. Turn off culling. I guess I could just turn off culling. That's a good point. Let's see. I'll just stop this program. Hopefully. Why am I doing that? Cull is... Yeah, let's just turn it off. None. Hey, wow, would you look at that? Okay. Are our vertices backwards? I didn't think they were. So 0202, wait a second. Hang on a second. Did you notice the position of the triangle is like on the right side of the screen? So does that mean the device coordinates for DirectX are -1 to 1? I thought it was 0 to 1. So I guess 0.2 is 0.2 from the center. But okay, that's fine. So it's here, but it's getting culled because why? 0.2 is the top. Wait a second. 0.2. And then 0.8, 0.8. What the? I think this is upside down. Right? Oh, is it going this way? It's going counterclockwise. No. 0.8, 0.8 should be down here. Would I consider myself a master coder? No, no way. I've been programming for, I'd say 20 years, but I only started programming systems languages 5 years ago. It's going clockwise, Y is up. Oh, Y is up in DirectX. Okay, that makes sense. I think. Right. I would have... Yeah, okay. I'm used to Y being down. So if this is instead... If I put that as -8 or 0.2, what is that going to look like? Alright, that's what I would have expected. Okay, that makes sense. Would I consider myself a master beta? You know, I'm pretty good at making bait posts on Twitter, I'll tell you that. Okay. Okay, guys, it's been 2 hours and 22 minutes. I think that's a good time to call it. We've got a triangle. That's the most hard, I mean, not the most hard. That's the big hump is over. So, I think next time we're going to get a 3D camera working so we can move around in the scene and look at the triangle from different angles. And we'll also figure out the culling and the vertex order and make sure that's all correct. But right now, I'm starving. I'm going to go cook some beef. Go to the gym. Actually, I'll go to the gym first and then cook some beef. And I'll see you. I said I was going to do Tuesday, Thursday, and Saturday. But as soon as I said that, I didn't stream for a week. So I'm not going to make any promises. But it should be Tuesday, Thursday, and Saturday. So thanks for tuning in. And thank you very much for the help And I'll see you next time.